Hi, this is Mr. Roix, and what I'm going to do in this video is talk a little bit about dimensional analysis. As I mentioned in class, dimensional analysis is really important for us in chemistry because we're going to be often converting between units, and to be able to set up a process to check to make sure that you've done all the calculations correctly, dimensional analysis is definitely the easiest thing to do. It allows you to get from here to there. So we're going to start off with a practice problem. The practice problem is going to be if we have 5.4 centimeters per second. So we have a speed of something going at 5.4 centimeters a second, and we want to get to miles per hour. Okay, so over here is going to be our goal, and the goal is going to be miles per hour. So how do we get from here to there? What we do is we set up a series of steps, which are basically factors that allow us to convert between labels. And, we're going to set up boxes. It's like multiplying by fractions. So let's start with we'll deal with the distance first. We want to get to miles, and we're in centimeters. So couple of different steps, and now I wouldn't expect you to memorize any of these factors. I would give them to you, but you still need to be able to use them. So how do we get from centimeters to miles? Well, I don't know the conversion factor between centimeters and miles, but I could probably come up with a few conversion factors that would allow us to get from point A to point B. And so let's talk about distance. If I am in centimeters, I could tell you that in 1 inch, there are 2.54 centimeters. All right. Now, again, I don't know inches in a mile, but I could get from inches to feet. So in, 1 foot, there is 12 inches. And now I can get from feet to miles because I do know that in 1 mile, there are 5,280 feet. All right. So now the last thing is we need this not in miles per second, but we need it in miles per hour. So I do know the conversion factor between seconds and hours, and I do know that in 1 hour there are 3,600 seconds. I'm running a little bit out of room here, but that's all right. I'll run it up here. Draw my line there. So now what I'm going to do is I'm going to make sure that I've set everything up properly before I do all the math. So let's double check here. Anytime we have something on the top, like centimeters, and something on the bottom, right, centimeters, centimeters divided by centimeters, or anything divided by itself, is 1. So they cancel each other out. And then if we look at the next thing, now we have inches. So we have inches on top, we have inches on the bottom, they're going to cancel each other out. And then we come over here and we have feet. And we have feet on top, we have feet on the bottom, so they cancel each other out. And then, well, we can't cancel miles because there's no miles down underneath, down here. But if we look, there's an hours, then there's no hours on top. But we do have seconds here and seconds here, so those can cancel. And so what we've done now is we canceled everything but our mile label and our hour label, and look what label we want to finish with, miles per hour. So now it's just a matter of doing the math. Now, you can do this a number of different ways. We can take the top numbers and multiply all the way across the top, and then we can multiply all the way across the bottom, and then we can divide top by bottom. Or if we want, we can take the top number and divide it by the next bottom number, and then multiply by the top number, and then again divide by the bottom number and multiply by the top number. Now you'll notice in the top numbers most of these are ones in this particular problem, so we don't worry about those. So for me, I would personally do it like this. I'd take my 5.4, I'd divide it by 2.54, and then I'd multiply, and then I'd divide it again by 12, and then I'd divide it again by 5,280, treating each of these like a fraction, 1 over some value, and then lastly I'd multiply by 3600. When everything's said and done, hopefully you got an answer of 0.12 miles per hour. Alright, we're going to try one more of these. We'll do sort of a straightforward one. What if I wanted to calculate out if I have 1.25 inches and I wanted to know how many kilometers that was? So how would we convert? So what we would do is we would say, we'd start with our known value, 1.25 inches, right? And we have to come up with a conversion factor. Again, you don't have to know many conversion factors, but the one, again, that I'm going to go back to is that in 1 inch there is 2.54 centimeters. Then, if I want to get to kilometers, I could, I guess, jump right from centimeters to kilometers, but let's say I go through meters first. So I could say in 1 meter there is 100 centimeters. And then lastly, now that I'm in meters, I know that it's easy to go from meters to kilometers. In 1 kilometer, there are 1,000 meters. So now all I have to do, and again how I would do this is I would multiply these values and then divide by this value of 100 and divide by that value of 1,000. And when we get to our answer is going to be 0.0000318. Easier to me, written in scientific notation, as 3.18 e to the negative 5th. That's how I'd write that one out. Anyway, so there's a couple practice problems. Why don't you go onto the Edmodo site where I posted the worksheet that you can try. I'd like you to try to at least get through the first 10 problems, or through 9 problem number 9 at the very least, and then we'll try maybe the other problems in class. But certainly, again, like I said, it's worth the effort now to try to get dimensional analysis under your hat so that when we are dealing with different units in chemistry, you'll find things much easier. All right, see you in class.